Okay, get ready for this. We're about to dive into a piece of tech that's so incredibly advanced, it feels like it just shouldn't exist. We're talking about a medieval masterpiece of engineering, and trust me, it's hiding a mind-blowing secret.
4 billion. Just let that number hang in the air for a moment. I mean, that's a number we throw around when we're talking about computers, right? Digital encryption, gigabytes. Not something you expect from a physical object hammered out of metal hundreds and hundreds of years ago.
So that's the big question, isn't it? How on earth could a 900-year-old lock possibly have 4 billion different combinations? It just sounds impossible. But the answer? The answer is just pure mechanical genius. All right, first, let's set the scene. We're not in some modern tech lab in Silicon Valley. No, we're going way back. We're in the Seljuk Empire, this huge Turco-Persian power that stretched all the way from Central Asia to what's now Turkey. And it was right here that some brilliant artisans created a security device that was just light years ahead of its time. Now, you gotta understand, this was not your average locking key. Not even close. This was a full-on combination lockbox, a heavy-duty safe, really, forged from solid metal. And it had one job and one job only, to be completely, utterly unbreakable. Think about it. No keyhole for a thief to pick. No simple latch to pry open. The only way you were getting in was if you knew the secret code. So, okay, how did you actually use this thing? The whole secret to cracking it starts right on the outside, with an interface that's, well, it's this beautiful mix of being incredibly simple to look at, but wildly powerful in a mathematical sense. So when you look at it, you see these 4 dials you can turn. And each one is covered in characters. We're talking about 80 different characters on each dial. Now here's the cool part. The key isn't something you hold in your hand. It's just a piece of information, a secret password, basically. It's a sequence of 4 specific characters. Your job is to spin each of those 4 dials, one by one, until you line up that secret code in a perfect row. And only then, only if you get it exactly right, do you even stand a chance of opening it. Okay, so that's the outside. Turning some dials seems simple enough, but the real magic, the real puzzle is what's happening on the inside. What's the actual physical thing stopping you from just prying it open? What's the barrier that the code is designed to beat? Right, here's the problem you're trying to solve. You've got the lid, and it's held down by this metal strap called a hasp, simple enough. But attached to that hasp are these 2 beefy solid metal pins, and they go deep down into the lock itself. So to open the box, you have to be able to pull that hasp and those 2 pins straight out. But you can't. Something inside is physically blocking them. And that is the million-dollar question, or I guess in this case, the 4 billion combination question, right? What is the secret link between those dials you're spinning on the outside and those pins that are stuck solid on the inside? I'll tell you what it's not. It's not magic. It's something even better. A jaw-droppingly clever piece of engineering. And here it is. This is where we get to the very heart of the invention, the soul of this incredible machine. The real genius of the Seljuk lock is something you can't even see from the outside. It's a hidden system, a series of internal gates that decide everything. They are the ultimate gatekeepers. Okay, stay with me here. This is the really cool part. Imagine that each of those 4 dials on the outside is directly connected to a thick, round metal disc on the inside, and each disc has a little slot cut out of it. Let's call these discs gates. So when you turn a dial on the outside, its matching gate spins on the inside. See where this is going? When you dial in the correct 4-character code, what you're actually doing is lining up the slots on all 4 of those internal gates. And when they're all perfectly aligned, you've just created a single open tunnel that goes straight through the whole mechanism. Okay, now let's connect the dots. Remember those 2 metal pins that were stuck? Let's connect them back to this beautiful continuous channel we just created. This is the aha moment. This is how a bunch of spinning gates actually decides whether the lock opens or stays slammed shut. It's actually beautifully simple. When you've got the code right and all those gates are aligned, that channel is wide open. The 2 pins on the hasp, they can just slide right through it, easy as anything. You can pull the hasp and the box opens. It's a clear road. But if even one of those dials is off by a single click, that means one gate is misaligned. And now the solid, uncut part of that gate is sitting right in the way. It becomes a solid wall of metal, physically blocking the pins. They can't move. They have nowhere to go. The hasp is locked solid, the box stays shut. And that right there is the core of its security. It's basically a binary system. It's either 100% open or it's 100% locked. There's no in between. You can't jiggle it or get it to partially open. The engineering is too precise for that. Think about it. One single tiny mistake out of 4 times billion possible combinations, and the whole thing just stays a solid block of metal. So when you take a step back and look at the whole thing, what you're seeing isn't just some old rusty box. It's so much more than that. It's a monument, really, a testament to just how clever people can be. I mean, think about it. There are no wires here, no batteries, no circuit boards, no lines of code. This is a solution that comes purely from a deep, intuitive understanding of physics and geometry. It's like this elegant little ballet of spinning disks and sliding pins, and it solves this hugely complex security problem with an almost shocking simplicity. It's just a fantastic reminder that you don't always need a silicon chip to achieve incredible levels of security and, well, computation. And that really just leaves you with this fascinating thought, doesn't it? The Seljuk lock is proof that we so often underestimate the past. It's like a little window into this world of forgotten genius. It shows us that the line between ancient machinery and modern computers is maybe a lot blurrier than we think. And it really makes you wonder, what other incredible secrets are just sitting out there, locked away in history, just waiting for us to come along and figure out the combination?